Hey, what's up, guys? I want to start off this video by giving you guys a shout out. I want to say thank you for all the hard work you've been doing on this online resource that we're doing, all the assignments, everything that we're doing. I want to say thank you, especially during these hard times. I know right now it's not easy, but I want to say it's been a pleasure working with you guys. We had our highs, had our couple lows here and there, but you guys have been nothing but great students. I appreciate you guys. Hopefully next year, my juniors, I'll see y'all senior year. Stop by my classroom anytime now. For my seniors, I have something for y'all later, so y'all stay tuned. Besides that, I appreciate my students. It was an honor. It was a lot of fun, even though y'all gave me a bunch of headaches, but it's something that comes with the job, and I love what I do, and I appreciate you guys. Always know I'm a message away, either through Microsoft Teams or on the hub. Now, for the students who aren't mine, same message pertaining to y'all. I'm pretty sure y'all's teachers miss y'all. If y'all ever need anything from them, once again, Microsoft Teams on the hub. Message, phone call away. Now, with that being said, let's actually jump into the assignment. Assignment 9 and 10, dividing polynomials. So, the thing that I'm going to start off with is the way that I wrote example problem number 1. The way that it looks is the same way it's going to be structured on the assignment. So, whenever you get this problem, I always want you guys to rewrite it in this format. It makes it much easier to understand and easier to solve. Now, the last several weeks we're doing nothing but multiplying polynomials. Today we're going to be dividing polynomials. Sorry about that. When dividing polynomials, you're only going to subtract the exponents, you know? That's what we're going to subtract, and they have to have the same base. If they're not the same, can't subtract. So let's actually begin. So our coefficients, that is the physical thing you're going to divide. So 16 divided by 4, we know that equals 4. 16 divided by 4. I'm going to put this in a box. That gives us 4. And then same base, same base. So 4 minus 2 gives us 2. So I'm going to write the base to the power of 2, or x squared. And then this is complete. Then I'm going to do my y's. That has a 6, that has a 3. So 6 minus 3 will give us 3. So it's going to be y to the power of 3. And you're complete with example problem number 1. Okay. So go ahead and copy that down, guys. And we're going to move on to the next part. So about that, how to make it a little better for you guys. Let's go to example problem number 2. So example problem number 2 gives us, let me erase that, put a 2 right here. This is going to be 40 x to the power of 3 plus 20 x squared plus 10x. And all that is being divided by 10x. Now, once again, they're not going to be like this. They're going to be just like example problem 1, but this is the easiest way, so you guys won't get confused. So, each of those top numbers, our numerators, are going to get divided by the denominator. So, 40 divided by 10, that gives us 4. 40 divided by 10, 4. And then, same base, x to the power of 3 minus x to the power of 1. Remember, it's never a 0, it's a 1. So, 3 minus 1 gives us x squared. So, next part. We divide the 20 and the 10. So 20, I'm going to write a plus because it's positive. So 20 divided by 10, that gives us 2. Then 2 minus 1 is just 1. So you can write it as 2x or 2x to the power of 1. But this is how it's going to be in your answer choices, of course. And last one, 10 divided by 10, once again positive because it's positive, that gives us 1. X minus x is the same thing as saying 1 minus 1, which is 0. No, you do not write a 0. Whenever they cancel each other out, they just cancel. And this is my answer. One thing I recommend whenever you guys are doing the assignment, always look at the answer choices. Process of elimination. Probably the first division is going to give you the answer right away. But always know, look at your answer choices and look at what you already have done. You don't have to complete the problem at times, but always look at your answer choices. So let's move to example problem 3. This is when I start picking up a notch whenever you don't have perfect divisions. You either have to reduce or leave it as a fraction. So example problem number 3. Say we have 3p to the power of 4 plus 7p to the power of 3 plus 9p to the power of 2. And all this is being divided by 8p. So let's begin. They all have the same base, so we can, of course, subtract the exponents. So now let's divide each coefficient. So first one, 3 divided by 8. Can 3 be divided by 8 and give us either a whole number? No, you cannot. You're going to get a decimal. So what I recommend, write it as a fraction, right? Because 3 divided by 8, well, not perfect division, leave it as a fraction. Then we subtract our p's. 4 minus 1, that is 3. So this is going to be p cubed. Let me go ahead and write the next. It's a plus, so I'm going to write plus. So can 7 be divided by 8? No, you cannot. Still going to get a decimal. So leave it as a fraction. So I'm going to write 7 over 8. 3 minus 2, minus 1 gives you 2. So p squared. My students know that sometimes I give y'all the answer whenever I'm trying to form it as a question. So my apologies. You guys know how I am. And then last one. Can 9 be divided by 8 evenly? No, you cannot. Leave it as a fraction. So this would be 9 over 8. P squared minus p to the power 1. 2 minus 1, that's just 1. So I'm going to leave it as p. Now, the question is going to get asked, Mister, why did you only put the base with the exponent on top but not at the bottom? Here's the thing. That's what we're going to cover on example problem 4. Because remember, can you have negative exponents? And that's what we're going to cover shortly. Remember, numerator is the top, denominator is the bottom. So let's go to example problem number 4. Remember, look at your answer choices, especially whenever they're fractions. Look at them. Example problem number 4. Say we have 2p to the power of 6 plus 6p to the power of 5 plus 7p to the power of 4. And all that is being divided by 2p to the power of 5. So this is a perfect one. Once again, all the bases for my exponents are the same, so we can subtract the exponents. So now let's just do the physical divisions. 2 divided by 2, that's 1, so I'm going to write 1. 6 minus 5, that's 1, so I'm going to just write 1p. Right? So this cancels that. Let's go to the next one. Can 6 be divided by 2? Yes, it can. And it's positive, so I'm going to write plus 3p. Well, not really, because 5 minus 5, that's 0, so it completely cancels. So there is no p. So you got to be careful. And then here's the important one. This is the very one that you have to notice. Can 7 be divided by 2 evenly? No, it cannot. So leave it as a fraction. So 7 over 2. And then 4 minus 5 is negative 1. So I'm going to put p, negative 1. Now, the first thing you're going to tell me, Mister, you said no negative exponents. That is true. You can't have them. So notice how it's a fraction, right? Because it's a fraction, if it's negative on the top, to make it positive, I have to send it to the bottom. So I'm going to rewrite my whole answer. this is going to be 1p plus 3 plus 7 over 2p. Answer. No negative exponents. Can't have them. And then let's wrap it up with the most difficult one you're going to have on the assignment. But trust me, I've said it long enough. Answer choices. Look at them. So, example problem number 5. I'm going to write this as 2v to the power of 4 plus 6v cubed. Let me write this better instead of a u. I have a bad habit of that. So this is a v plus 8v squared. And all that is being divided by, ooh, here's a good one, 10v4. So get ready for this one, guys, because we're going to be reducing. So 2 divided by 10, is that possible? No, it's not. So I'm going to write 2 and 10. Now 4 minus 4, that's 0, so they cancel. So we physically have a fraction. Now can this be reduced? Yes, it can, and I'm going to show you how. First off, always pick the little number, 2 or 10. Which one's smaller? 2. So you ask yourself, does 2 fit into 10? Does it? Does 2 fit into 10? Yes, it does. How many times? 5, because 2 times 5 gives you 10. So that means that 2 fits in both. So 2 divided by 2, that's 1. 10 divided by 2, that is 5. So that's the first answer. That's the first. I'm going to write out the rest because, yes, you're going to reduce them. So, next part. I'm going to have 6 over 10. First, let's reduce, then we do the subtraction. Once again, does 6 fit into 10? No, it doesn't. Does 10 fit into 6? No, it does not. So, we have to reduce. Always pick the little number. 6 or 10, 6 is smaller. So a number from 1 through 6 fits into 10. 1 fits into both, but if you divide both numbers by 1, it's the same number. 2, does 2 fit into 6? Yes, it does, 3 times. Does 2 fit into 10? Yes, it does, 5 times. So right now, our number is 2. I'm going to write that right now. What about 3? Does 3 fit into 6? Yes, it does. But does 3 fit into 10? No, it does not. 4, does 4 fit into 6? No, sir. What about 5? Nope. 6 fits into 6, but does it fit into 10? No. So the only number they share in common is 2. So divide each one by 2. 6 divided by 2, that is 3. 10 divided by 2, that is 5. And now let's do the exponents. 3 minus 4, that is -1. So I'm going to put v -1. I'm going to keep that as my answer for the meantime. We'll fix it at the end. And then last one, 8 and 10. So for this one, I'll let you guys pause the video and try to reduce it on your own. And I'm going to start beginning now. So the number they share in common, by this point, you should have chose 2. So 2 fit into both. 8 divided by 2, that is 4. 10 divided by 2, that is 5. So my answer is 4 over 5. Pardon that. You did not see that. And then 2 minus 4, that is -2. And I will keep that on top because that's where I did the subtraction. And then we look at all our answers. The first one checks out. That's my answer. This one cannot have a negative. Send it to the bottom. So this is going to be 3 over 5 v, or v to the power 1. And then the bottom, can you have this? Send it to the bottom. So this will be, let me go ahead and take a knee. This is going to be 4 over 5v squared. Now let's combine all three as our answer. So our answer is going to be 4 over 5, actually, let me write that up here. Get rid of this, since I ran out of space. I get the one that has highest exponent. So 4 over 5 v squared plus, this is the next one that has one, 3 over 5 v, and last one is 1 over 5. Answer. Because remember, it's always whatever has the highest exponent in the descending order. So, that being said, guys, that will complete today's video. If you guys need anything, message us. Simple message, simple call. Mr. I need help. I'll personally do a little video conference and help you guys out. Have a good rest of the day. Don't forget, give me a like and subscribe. Bye, guys.